Greetings everyone, my name is Jay Harisnanda. I'm the team lead of Space Hackers. The problem statement ID is SAS 25125 and the problem statement title from student innovation and the theme that we took is space technology and from it is from the category is from hardware. The the idea is to create a reusable. We intend to create a reusable rocket. We named that as Reapulses. Aim of our project is to create a rocket with the capability of launching a multiple satellites at low Earth orbit. Which is to create to reduce the cost compared to the traditional way of launching, and to reduce the space debris also, and any other waste types of waste which is due to the launch of the rockets in a traditional way. And the innovation and uniqueness in this project are which you would ask that is already an existing idea, but the parameters that we are going to use in this project in this rocket are completely different, completely unique. We are using hybrid propellant for the re-landing the rocket. This launch of the reusable rocket is with the useful payload, and also we intend to make this for educational purpose, like for helping the students to understand the launch of the satellites and the usefulness of the reusable rocket. And the technical approach of this idea, which I have split in this into a four major parts, like launch, reaching a maximum height, stabilizing the axis, and propulsive landing. In these stages, there are five important points like propulsive and engine restart technology, and guidance navigation control, thermal protection system, and landing system, and reusable structure and materials. These are the important things which will eventually will present in any type of rockets. The important thing in the reusable rocket is the engine restart technology and the landing system and the reusable structure materials. These 3 points are important. These 3 points are new. um, in propulsive and engine restart technology, the engine, of course, the engine has to be started multiple times. For that, we have used a TEA and TEB type of igniters and hypergolic igniters. The thrust which are created, which is directly depends upon the nozzle design. We have designed the nozzle according to that to create a high thrust based on the area ratio and the pressure configurations. The guidance navigation system, the inertial navigation system, which contains accelerometer and gyroscope, gimbal, and like that. And also we will have a GPS. In inertial navigation system, we do not require any external reference lines, but in GPS we would require a satellite to watch our product. And also the guidance we have used fins for controlling the direction of the aircraft in during the re-entry stage. And the finally the thermal protection system, we have used the heat resistant tiles and panels, and also the ablative coatings like phenolic impregnated carbon ablators, PICA, and CNF. CNF stands for carbon nanofiber. And then the landing system, we are using a leg type legs for the landing purpose. The legs cones which are made of the which are made which crushes the cores to absorb the impact, and the propellant reserved for the controlled landing burn, which says that the hybrid propellant, we are not going to use the hybrid propellant for the launching purpose. The boosters are used, the solid propellants are used for launching, and then during the re-entry stage the hybrid propellants are ignited, and using that the landing is made. As I already told, there are four stages: launch, reaching maximum height. After reaching maximum height, the separation of the boosters are occurred to reduce the structural mass of this prototype, and then stabilizing the axis. When during the re-entry stage, the fins plays very important role for stabilizing the axis. After that, uh, after a certain height from the ground, the ignition of the hybrid propellant occurred, and then the propulsion landing method, then this ignition of um, the legs landing system will occur. The reusable structures and materials. The materials are selected specifically for the reusable type, like aluminum, lithium, and alloys, advanced alloys, sheet metal, stainless steels, and some other carbon composites. And we have used parachutes for the safety purpose. Uh, and the boosters are disengaged after the disengagement of the boosters. The boosters will also engage the parachutes for landing them safely. And then the feasibility and viability of this project. The hybrid propellant, we are using the hybrid propellant here, which has the low risk of burst when compared to the liquid propellants, and also which is very reliable. As a prototype, we can use a hybrid engine, but in the actual product, we are using liquid engine because hybrid propellant gives a low thrust. We can control the thrust in the hybrid propellant, but the value of thrust is low compared to liquid. Rockets' reusability are already proven worldwide, so our idea is practical and viable to function as a working prototype. Challenges Challenges are cost, safety, approval, and making the landing accurately. Since we are starting from the small working prototype, we will be able to correct the designs and modify them in the future. So it won't make any problem unless we skip any stages. Impacts and benefits. The impacts and benefits are which is economical because by creating a reusable rocket we save lots and lots of money. We are making a rocket very cheaper compared to the traditional methods, and also we will be able to help the many companies to send satellites and to teach the students about the launching low earth orbit satellites, and also the method of the way of reusable launches. Social. This helps to reduce the pollution of the ocean due to the waste of the launch, and get rid of the debris due to that. And safer fuel. Compared to the liquid type of rockets, hybrid propellant is very safer, much more safer. National and strategic, which supports India to create a reusable rocket, which I mean preliminary stage. If we were able to become a startup or as a company, then it will eventually reduce the dependence of the foreign land services, and also this will create a much more impact in India. Research and references. Some references, we took some references from the WS 520 Japanese rocket, which is completely solid rocket, but even though the configurations of the rocket will be similar to ours, the calculations which we took from the NPTEL classes, and also the online sources, Google, ChatGPT, and then the configurations the calibrations that we took from Honda's first reusable launch, which is a prototype, and also the SpaceX Falcon 9. Thank you. This is our idea.